This is the 2008 multiple choice non-calculator portion. This is part 1. This is 2008 AP AB calculus exam. So I wanted to just go through some of these problems in order and see how much we can get through. So number 1, we have a limit of a function as x approaches infinity, and anytime x is approaching infinity, we can think of this as finding horizontal asymptote, which means that we want to compare the degrees between the numerator and the denominator. And if the degrees in the numerator is higher, if the degree in the denominator is higher, then we know the limit is going to go to 0. But if the degree is the same, then we simply look at the leading coefficients. So what we can do here is we can distribute through and expand and FOIL and see if we can identify and combine like terms and get a better picture as to what the degrees will look like. So I'm going to rearrange the highest degree first, combine like terms. So I'm left with negative 2x squared plus 7x minus 3 all over x squared plus 2x minus 3. Notice that the degree in the numerator and denominator are going to match. So because they have the same degree, we just look at the leading coefficient. So negative 2 over 1 is simply negative 2. Okay, number 2, we want to find the indefinite integral of 1 over x squared. This is simply going to be using power rule. Now, if it is 1 over x to the first power, then we have to use natural log rule. But any other degree, whether it's 2 or 3 or 1/3 or 1/4, we have to use power rule. But if we want to use power rule, we have to get it in the right place. So this x squared needs to be sitting up in the numerator. And once you do that, x to the negative 2 becomes x to the negative 1 over negative 1 plus c. And then that simplifies to be negative x to the negative 1 plus c. Okay, number 3, if f of x equals quantity x minus 1 times parentheses x plus 2 quantity cubed, then f prime is equal to. So if we want to find the derivative of two functions that are being multiplied together, we want to use product rule. And then within product rule, there is also a chain rule portion involved. Another option is you can expand everything through, but being to the third power, it may just be more efficient to just go through product rule and chain rule. So product rule says f prime g plus fg prime. And then we can apply chain rule when it's appropriate. So f prime, x minus 1 becomes 1, x squared plus 2 cubed stays, and then the original function f times g prime. So g prime is 3, bring down the 3, keep the parentheses, subtract 1 from the exponent, and then multiply by the inner function's derivative. And then once we have that, we can identify a leading coefficient as to be x squared plus 2 quantity squared. And then the remaining term we can just leave in the brackets and then combine like terms. And then once we have that, then we can match it up with the appropriate solution, which is D. Okay. Number 4, we want to find the indefinite integral of sine of 2x plus cosine of 2x. We can go through use substitution, but this is also simple enough where you know the integral of sine is going to be a negative cosine, and the integral of cosine will be a positive sine. And if you have just a linear portion that is inside the parentheses, you can just go ahead and know that your integral will have to, the indefinite integral will have to account for this u value that is more than x by the reciprocal of this derivative. So the derivative of 2x is 2, so we just need to have a 1/2 in front. Same thing with this 2x will produce a 1/2. And because integral of cosine is a positive sign, we have the integral of cosine is positive sine, so we have 1/2 sine of 2x, but integral of sine is negative cosine, so we have negative 1/2 cosine of 2x plus 1/2 sine of 2x plus c. Right. Or we can just go through use substitution, but I think these problems are easy enough where we can take that shortcut and pull the reciprocal of its derivative out in front. Number 5, we have the limit as x approaches 0. So if we have a limit problem where x is approaching a real number, then the first thing we do is we plug in that x value and see if it comes out to something that will give us a real number. If after we plug in and we get an undefined, then we can look to see, is there anything that we can factor out, simplify, cancel out, and then try re-plug in again. So in this case, when we plug in, we're going to get 0 over 0. So that's an indeterminate form, meaning that we can continue and we can factor. And when we factor out the x squared in the numerator and denominator, those cancel out. So then we can try replugging in our x value, which is 0. And we're going to get 0 plus 8 over 0 minus 16, which is equal to negative 1/2. Okay, number 6, it says let f be the function defined. Which of the following statements about f are true? So we have a piecewise function here, and we have 3 options here. The function has a limit at x equals 2, the function is continuous at x equals 2, and the function is differentiable at x equals 2. So let's go through and talk about continuity conditions. So continuity condition says that the point needs to exist first, and if the point exists, then we can check to see does the limit exist, and if the limit exists, then we can compare 1 and 2. Does 1 and 2 give us the same y value? If they do, then we know that the graph is going to be continuous. So let's go through our conditions here. We can find the ordered pair. So does f of 2 exist? F of 2 is 1, so we see the point exist. Does the limit exist? So the limit is going to be this function because the graph is going to be on either side of 1. Either side of 2 being this function. So we can just find the limit of that function. And we, just like before, when we want to find the limit, we can plug in the x value. If that gives us an undefined, then we can simplify and factor. So if we plug in a 2, we get undefined, but we can factor difference of squares, x plus 2 times x minus 2 all over x minus 2. The x minus 2 cancels out. We're left with x plus 2. And then we can plug in the target x value. 2 plus 2 is 4. So now the limit exists, the ordered pair exists. However, condition 1 and 2 does not agree. So that means that the graph is not continuous. And if the graph is not continuous, then there's no way that the graph can be differentiable either. So in order for it to be a smooth curve, it needs to first pass this condition of continuity. And because continuity fails, we can also say that differentiability also will fail. Okay, so therefore the only true statement is 1, that the limit has that the function has a limit at x equals 2. Okay, number 7, a particle moves along the x-axis with a velocity given by v of t for time t is greater than or equal to 0. If the particle is at position x equals 2 at time t equals 0, what is the position of the particle at time equals 1? So if I want to find my final position, then the formula is given here. If I want to find my final position, I need to start with my initial position plus the accumulation of distance traveled. So the accumulations of distance traveled is simply going to be the definite integral of v of t dt from 0 to 1, because my starting position is at x of 0. So x of 0 is 2. Now to find the definite integral of v of t, we can just go through power rule here. V of t is 3t squared plus 6t. This will give us 3t cubed over 3 plus 6t squared over 2. And then that simplifies, and we can plug in our upper and lower bounds, which gives us 1 plus 3 minus 0, which is 4. And so we have the integral of v of t from 0 to 1 is 4. So that's the distance traveled plus our starting position will give us our final position at 6. Okay. Number 7, a particle moves along the x-axis. Number 8. if f of x is equal to cosine of 3x, if f of x equals cosine of 3x, then f prime of pi over 9 is equal to. So if I want to find the derivative of, if I want to find f prime of 9, I first need to find the derivative of cosine of 3x. And then we can evaluate it once we find the derivative. So the derivative of cosine of u is negative sine of u times u prime. So that's exactly what we can apply. Negative sine of 3x times 3, negative sine of u times u prime, which gives us negative 3 sine of 3x. And then we have our derivative, so we can evaluate our derivative at pi over 9. So plug pi over 9 in for x, which we get 3 pi over 9, which reduces to be pi over 3. And so sine of pi over 3 is root 3 over 2 times negative 3, which gives us negative 3 root 3 over 2. Okay. Number 9. The graph of the piecewise linear function is shown in the figure above. If g of x equals the definite integral of f of t from negative 2 to x, of which of the following value is the greatest? So let's first figure out what the relationship is between g of x and f of t. So if I want to find the greatest value, I will need to find where my slope is equal to 0. Or I need to find the derivative and figure out whether this will be a maximum or not. So if I find the derivative of g of x, that will leave me with f of x, because the derivative of g of x would mean that I'm taking the derivative of the definite integral, which is going to cancel out. We can simply use second theorem of calculus, plug in x, which is f of x. So basically, that's saying that this is the derivative graph of g of x. And since f is the derivative graph, the max is going to occur when f changes from positive to negative. So that's going to be where the slope is 0. And slope is 0 at x equals 1. So then we see this portion is above the x-axis, and then to the right of 1, we see the portion is below the x-axis. So we have a positive slope followed by a negative slope, meaning that max occurs at x equals 1 because g prime changes from positive to negative. So therefore, g of 1 would be where our value for our function will be the greatest.